and welcome to Cherry Pie Math. This video is going to talk about estimating irrationals, especially the irrationals concerning square roots. So before we begin, you should be comfortable with the idea of a number line, and you should be able to know rational versus irrational, and you should know, or at least be familiar with, the concept of pi. You don't have to be an expert on any of these except maybe the number line, but you do have to have seen these before. And if you haven't, go ahead and check out the videos that I've made that will explain those, except I haven't made a pi video because pi is just a number. Okay, so to start with, I want you to look at this and pause the video and figure out in each cell which number is bigger. So just pause the video, take a minute, and see if you can figure that out. Okay, so I'm going to give you the answers now. Hopefully you pause it. If not, that's okay. I also would not have paused it because I hate touching the computer once my video is playing. So in 1.5 versus 1.6, I'll mark it in black. This is bigger. This is bigger, this is slightly bigger, this is technically bigger, this is bigger, and this is bigger, and this is bigger, and this is bigger. Okay, and we're going to talk a little bit more about that. Well, actually, no, we won't, so I'll just talk about it now. These ones should have been not too hard because you can obviously see like 4.03, even though it's like 0.03 more, it's still 0.03 more. So it is by definition more than just 4, because 4 is technically 4.000. There's nothing left. It gets a little bit harder once you don't have familiar digits. So like in this one, we had 9 in the 10th place, but this one had an extra bit in the 100th place. So that one was easier. But in this one, we have no matching numbers, really. The easiest way to tell is to look at that first spot, the one that they both share, and see which one is bigger. In this case, that one has a bigger number in the 10th place. Or like in this one, it had a bigger number in the 100th place because they both had 0 in the first one. So if they have the same like digit in that decimal spot, then you have to look to the next one to see which one is bigger. In these ones, we had fractions, and what you would have to do is just convert it to a decimal. So like 1/2 is 1 divided by 2, and that would be 0.5, and that would be smaller. And this one, I actually don't know what 1/6 is, but I do know that is equal to 1/8. 1/8 is smaller than 1/6. You could have also converted 1/6 to a decimal in order to compare it. Either way would have been fine. The moral of the story is you need to A, have them in the same format, so you can only compare decimal to decimal or fraction to fraction, but also B, comparing the digit spots, and that'll help you know which one is bigger, and that'll help you put it on a number line. So for the rest of the lesson, we're going to be talking about irrationals, specifically in relation to square roots. So just to remind you, irrationals are numbers that can go on a number line, but never end or repeat decimals. And because we can't actually write it all out, we usually have symbols. So like pi is an example, E is another example. And in this video, we're going to be focusing on another very common irrational number that you'll see, which is the square root of 2. And the reason we use the square root of 2 is because it's the first square root that doesn't go into anything else. Like 0, square root of 0 is 0, square root of 1 is 1, square root of 2, irrational. So just a reminder, again, square roots are numbers, numbers that multiply by themselves to make the original radicand. And radicand is a fancy word for if you have a square root, the thing on the inside is the radicand. Okay. Most square roots are irrational. A lot of square roots that you'll see, especially on paper, are going to be perfect squares, like 4 is a perfect square because the square root of 4 is 2, or 9 is a perfect square because the square root of 9 is 3. But most square roots in the real world are irrational, because if you just pick any number like 15, the square root of 15 is going to be irrational. It's going to be a decimal that never ends. But we're going to practice this with the square root of 2. So when we think about the square root of 2, remember a square root is something we multiply by itself to get whatever's in the radicand spot, right? So let's pretend like 1. Let's see if the square root of 2 is 1. 1 times 1 is 1. That's too small. Too small. So let's try the next biggest number is 2. 2 times 2 is 4. That's going to be too big. We want this number to match this number, okay? So we know that 1 is too small and 2 is too big. So the square root of 2 is going to be between 1 and 2. So I'm going to do this. I'm going to put it on my number line. I have a 1 on that side. I have a 2 on the other side. I know that in the middle is 1.5, and I'm actually just going to write some decimals here. That should be 1.6, 1.7, 1.8, 1.9, and then we get 2 because 1.10 doesn't make any sense because that would be 10 in the decimal spot, so you would just have to change it. So after 9, you go back and you change numbers, really. Okay, so we know it's between 1 and 2, so let's try 1.5 and see what happens. And I'm just going to do a bunch of notes over on this side. So 1.5 times 1.5, where is my calculator? Here it is. If I multiply those two together, 1.5 times 1.5 is 2.25. That's too big still. So let's go down 1. Since 1.5 was in the middle, I'm just going to go down 1 and do 1.4 times 1.4. And that's equal to 1.96. That's too small, and so now we can narrow it down. We know it has to be in this spot somewhere. So now it's like every single time you're zooming in. So first I took 1 and 2, like if I had a number line and I had like 1, 2, 3, 4, blah, blah, blah. I took this part and I zoomed in for this line, and now I'm going to take this part and I'm going to zoom in. So I'm going to have 1.4 and 1.5, and then I do the same idea. I have 1.41, 1.42, 1.43, etc. Because every time 5 is always going to be in the middle. Since each decimal place is out of 10, 5 is going to be in the middle. And so that's just kind of a nice starting point. So that's what I'm always going to start with. Every time I'm introducing a new decimal spot, I'm just going to try 5 and then I'll adjust accordingly. Do I want to go up or do I want to go down? Until I find one that's too small and one that's too big, because then I know it has to be in the middle of those. So let's try again. 1.45. 1.45 times 1.45 is 2.1025. That's too big. So let's go smaller, 1.44. So 1.44 times 1.44, or 1.44 squared, is 2.0736. That's also still too big, so let's go down again. So 1.43 squared is 2.0449, still too big. 1.42 times 1.42 is also too big, so now we'll try 1.41 times 1.41, and that is less. So 1.41 squared is 1.9881. So now I know the next one has to be in between here, and I can just keep doing that. We can keep going. So every time we have a new decimal place to try, we're going to use 5 as the next digit, and then we'll adjust accordingly. So if we try 5 in this spot, for example, I'm going to do 1.415 squared, and honestly, you just keep doing this over and over. Usually if we do it by hand, we won't go more than like 1 or 2 places because it's just super annoying, as you can tell. Okay, so this is too big. So let's try 1.414. And that is too small. So that means it has to be between that. And we always take the one that's lower because we don't want to overshoot it, right? So like even here, I took the 1.14, and this one I took the 1.41. Now I always take the smaller one. So I know that this one's going to be a 4, and then we try it again. So now I'm going to try 1.4145. So I'm going to let you try that one and try to see if you can find the number that's going to go there. We start here, test it, see if it works. And if it's too big, then we try one less. If it's too small, like let's say it's actually going to be a higher number, then you would go even bigger. So like just to make sure that that's where you stop, right? You always want to make sure that you see what's too small and what's too big. We can use this method to estimate where things would be on a number line, but since we're going to be eyeballing it, what matters most is the 10th place digit of the decimal. So for example, going back to this, if I was to put this on a number line, like it's going to go on forever, right? What really matters is the 1.4. And then because on a number line, when you look at this like from far away, 1, 2, 3, 4, it's going to be like right here. And whether or not it is exactly where it's supposed to be is not as important as did you figure out what numbers it's supposed to be between, and can you kind of eyeball what fraction, what decimal you have left over. So let's kind of think about more number lines here. So let's use pi. Pi is an excellent number. It's one of my favorite numbers. I even have a channel named after it because I think Cherry is such a cool last name, and then Cherry Pie, of course. So we know that pi is about 3.14-ish, and you can keep going. So where would you put pi squared on the number line? So take a minute and think about that question. Where would you put pi squared, and then where would you put the square root of 2 squared on a number line? Okay, so we know that pi is about 3.14, so we can say that pi squared is roughly around 9-ish. Because it's only 0.1 bigger. It's not like it's really close to 3. It's not closer to 4. So we can kind of guess it'll be around 9-ish. It'll be slightly more than 9. But it won't quite be to 10. And then where would you put square root of 2 squared on a number line? This is actually a trick question. So if you think back to when we learned about square roots and squares, they are inverses of each other. They actually undo each other. So if I square a square root, I'm actually just left with whatever is in the middle, and that's just 2. And we know where to put 2 on a number line. We put it on the spot that says 2. So some things to remember. While a number line requires eyeballing it, you can still get a pretty good estimation through guess and check. Like the method we saw where we just kept trying 5 as our new decimal digit, and then we would adjust accordingly. And like I said, the 5 method to try new digit is very useful because it's just kind of the middle, and then you can see whether to go up or down. And then a lot of square roots are irrational because they never end. When you're doing it by hand, you'll often have perfect squares, but it's nice to be able to estimate them by hand as well for irrational numbers. Okay, I hope that helps, and good luck.